Welcome to week 8 of distance learning. Let's go to the whiteboard. Hello, Math 1. Mr. Osborne here. Going to give you a little introduction to your work this week. Okay, so your objective is going to be to factor out a greatest common factor from a polynomial. And we want to do that so that we can solve some equations using the zero product property. That's just a fancy way of saying, anything times zero equals zero. But that's really quite powerful because you can use that to your advantage to answer all kinds of problems. And this will be something to do for many years to come. Okay, so your learn task, the first thing you should do on Monday is an iReady lesson and quiz. And it's going to be about exponent rules, integer exponent rules. And this should be a refresher because the exponent rules are very helpful when it comes to factoring out polynomials. So on Tuesday and Wednesday, you'll be working on your do task, and that will be a flipped algebra task about pulling out greatest common factors from polynomials. We'll talk more about that in just a moment. Thursday, we meet up for our academic meet, and you want to make sure that your learn and your do tasks are completed so you can participate. And then Friday is left over for you to make sure you're working in iReady in your MyPath tasks. If you have any teacher assigned MyPath tasks that you need to do, actually scratch that. If you have any teacher assigned iReady tasks that aren't done yet, please make sure those get done. Those are actually really helpful in raising your grade because of the kind of category that they fall into. All right, let's look some more about the greatest common factors in polynomial. Okay, so remember, your objective this week is to factor out the greatest common factor from a polynomial. And once that's done, you can use your factored form in order to solve equations. Okay, so the guys, the algebros that do the flipped algebra, they do a great job, and their approach is going to be really kind of a number approach where they break terms apart. And I'm going to do the same thing but approach it from a slightly different direction, and we'll just kind of work through some examples. Before we do the examples, I want to remind you of one particular exponent rule because we'll use it even right now, and that is when you multiply same base, x squared times x to the third, you simply add the exponents. So x to the squared times x to the third power is x to the fifth power. Okay, so let's factor out 4x minus 12. I'm going to take sort of a geometry approach, and I'm going to rewrite the problem kind of this way. So I've drawn the box and I've put each term inside the box. Okay, now I ask myself, what's the largest number I can divide 4x and negative 12 by? What's the largest thing I can pull out of that? Well, we can see we have 4 is common to both of these. So I'm going to put that here on the outside. What do I multiply 4 by in order to get to 4x? Multiply by x. What do I multiply 4 by in order to get to negative 12? Well, 4 times negative 3. And bada bing, bada boom, we have our factored form. And sure enough, if we distribute it, 4 times x is 4x, 4 times negative 3 is negative 12. Great. So here's our factored form. What if we've now made this an equation, and now we can solve it because now we have an equal sign, we can actually solve what is this thing, what is the value of x. Well, I'm going to use my factored form to answer this. So I know that this is the factored form. Now you can almost see what the answer is here, right? What do I put in here for x that when I multiply it by 4, it goes to 0? Well, 3, right? Well, what we want to do is we can get there just realizing, I'm going to split this in half right here. I've got these two things being multiplied, 4 and this. And so I have two little things I'm setting up here. 4 equals 0, which is kind of ridiculous, right? That doesn't make any sense. But if I set this piece, x minus 3 equals 0, I can solve this, right? Add 3 to both sides. X equals 3. There's my solution, which makes sense because when I plug it back in here, 3 minus 3 is 0. 0 times 4 is 0. Or if I even plug it back into here, 4 times 3 is 12. 12 minus 12 is 0. So it works. Let's look at this example. Same thing again. This time, though, I also have an x in common. I know the 4 will come out because you can see it's the same. It's much the same polynomial. So the 4 will come out, but there's at least one x in each of these terms as well. So 4x times what is 4x squared? Well, times x. 4x times x is 4x squared. There's no using my integral rule here. And 4x times what is negative 12x? Well, minus 3. Negative 3. So here's our factored form. There's our factored form. Great. And if I took this and I turned it into an equation, I could solve this now. Ooh, look at you, solving a quadratic. So I have these two different pieces, and I set up one, 4x equals 0, and I solve this, divide both sides by 4. So here's one solution, and now I set this one. Add 3 to both sides. So I have two solutions to this equation. There's different ways you can write this. In the video, you'll see the guy write it this way. So he's saying that x can equal 0 or x equal 3. Either one of these values will solve this equation. Let's do one more just so you can see when things get bigger, because we can still handle it. Okay, so 14x cubed minus 21x squared plus 7x. Let's factor that. Okay, I could see there's at least one x in each term, so I can pull out an x. And I can also see that 7 is the largest number I can divide into each one of these coefficients. So my greatest common factor is 7x. 7x times what gives me 14x cubed? Well, 7 times 2 is 14. X times x squared gives me 14x cubed. 7 times what gives me negative 21? Well, negative 3. X times x is x squared. And 7 times what is 7x? Well, 7x times 1. So my factored form looks like this. Okay, so I had to move the camera slightly. But there you go. So now we have a way that we can factor out larger polynomials. Factoring polynomials is something you're going to be doing for a long time to come. So you're going to see it next year, the year after. This is going to be a regular occurrence anytime you're working with polynomials. There's all kinds of varieties of techniques for factoring, and it's just a matter of building up your repertoire because the polynomials will get more complicated as time goes on. All right, so hopefully this makes some sense. I did this really late at night in the dark. I miss you guys. So when you come, make sure you turn on your camera so we can see one another. Mr. O, hopefully we'll get some rest now. Miss you guys. Mr. O out. Bye.